This is over here. IntelliJ. What are you doing over there? This is our existing project, so I'm just going to do a new project. And for this, well, I guess I should try to just do the spring dot, yeah, start at spring dot start or start dot spring. Oh, that way I can just start coding once I'm ready. So I'll bring this in. I'll add web. I'm not going to bring in Spring Security right now because we know that the default behavior of that is to lock it down. So I'm going to bring that in later like we did in our auth thing. So just like with the auth, we're going to do it like we did last time. We bring in all the dependencies later. So if you're wondering why I'm not bringing in Spring Security, we're going to do it the same way we did auth because we know how Spring Security by default locks down your entire system. So we don't want that preventing us from doing work. Web, right? Again, I did web, right? Oh yeah, I did web already. And then need JPA. Bring in SQL. Getting any?
Should that be MySQL?
Yes, it is. Thank you. There it is. Thank you. Getting any? This reminds me like I think I'm forgetting something. Oh, no, that build Gradle. That's one. Yeah, this one.
JPA, MySQL, and web.
Yeah, it's just those three. And then the other ones we added, the JWT security and validation, we all added afterwards. So those are added later. Yep, so it's just those three. Good. There's definitely more, but this is the three we add via Spring Initializer. So generate. I called it demo again, so I'm actually not going to use that
You
one
actually
again.
made that a Maven, not a Gradle.
Oh, it's Maven. Thank you. Demo. We're going to just call this QR. We're going to have fun with it. QR matrix. I'll give you a code name for it. The QR matrix, we'll call it. Generate that project instead. There we go. Show Finder. Move it to no. They put that projects. Where is it under documents? Now remember where our projects are stored for IntelliJ. There they are, idea projects. So users, your name, your user account, idea projects. Here, and extract it. Zip. So now back to IntelliJ. We'll open that project. So click on this and just click open from here. Don't click on any of these. You want to open that folder. So just a reminder for anyone who hasn't done it in a while. Remember that. This window because we're not working on Spring Boot today. All right. So here, what I would normally start with, there's two kind of systems I might do. The first item is I'll just create a text file in the source that I'll delete later. So just go to file. And from here, I'm just going to write some notes, just write my thoughts. And then as I write my thoughts, if I realize, hey, this is the class, I can build this class, I'll start building those out. So I start from there. I'll open this up so that it's expanded.
Just to let you also know,
Yeah.
I've used the scratch papers in the bottom. It's pretty cool too. It just makes general notes, and you can do a scratch.
Sorry, the what?
If you right click and you wanted to say, you could do like a new file. When you did new,
Yeah.
you could do a new scratch file,
Oh, what is that?
and then you can make it into a text, and it'll go into the scratches and consoles. So then you could do like a text file or even a Java file. You can make
IntelliJ
any
feature.
files into scratches.
That's a cool feature of IntelliJ. Nice.
Yeah. But just keep in mind when it puts in your scratches, these scratches are kind of universal, meaning when you open up other projects, those scratches might be still in those from other ones. So it's good if you had these as notes
Ah,
for other
Scratches and
projects.
consoles. So you could just rename this then to QR matrix. That way you know it's for that project.
Hmm.
Matrix, whatever.
But no, the scratches are just pointing it out there for people also. I
That's
mean, the
not
way
bad.
you're doing it's good as well, but I'm just pointing that out down there as well.
I didn't know that IntelliJ had that. That's cool. Again, I tend to just use text TXT because I've used much simpler IDEs. Visual Studio Code doesn't have that. I can do that. So
No, I agree as well. Either way, just
That's
pointing
what
it
I
out.
all I need is just a place to type out my notes instead of me constantly starting with just writing comments everywhere that I got to delete later anyway. This is a file I can delete eventually, and even then I can keep it. This is something I can use indefinitely. I can add to it, remove from it, check marks, all that fun stuff. So this is something that I do sometimes. Mostly what I tend to have is a actual code file called test.java or test.js where I can write small snippets of code. But for the moment, I'm going to do this. So QR project. So if I'm thinking about it, we know we need items. We have items. These are the things that we're tracking. We have items that are going to be tracked. They have an ID. It might be nice to maybe use UUID for this. So that way it's very, very unique and we get a decent QR code instead of just getting the numbers 1 through 100. So it might be nice to have that. That way it's a little more robust and a little more filled out. Not a big deal. And again, for version 1, I can always keep with ID. And if I don't know the syntax for UUID, I don't need to. I can also just come up with my own ID generator that can be a number, date, time, and then a name about the item. So I can always just come up with a very unique naming system here if I wanted to. I need an identifier for the QR code. This is an identifier. This could also be a separate thing. So something I get to decide. This is something I get to decide. The main thing here is the identifier for QR code. Like that. Other than that, like I said, I don't really need much else on there for the item itself. Name. Didn't get the name of it. So I got that. So I know I can, the main system here, under Java, under this, I can start with my package, models, and create the first model. Even though I'm not going to do anything with it, I'm just going to create a model called, do I like the term items? Yeah, item's fine. Item. And your names don't have to see the same as mine. Next item I know I need to have is we have locations, and these are physical locations, right? Now here's the thing I get to think about. So here's what I get to think about. We have locations, and then people can hold the item. So people and locations can hold items, right? So now I need to figure out something that I can call that will refer to either a location or a person, right? So I need something that'll tell me that the item is either with a person or it's in a location. And so I need to be able to mark either one of those as something else. So I'm not sure what location is the right word for this, because that could be where location is where it's currently at. So now this is where I get to find some, I get to look at the like I would probably pull up like a thesaurus or something to start thinking of other terms that I could use. Because locations is kind of sticking as 2 items. These are my, it could are marked as a physical location like a warehouse or a store or a vehicle. And then the people are that, and now I need to know where the item is. Where's the location of the item? Is it at a location or is it at a person, with a person? And so the term location doesn't really, it will fit for item, but now I need to change one of those. So open to ideas. This is something where I might even ask someone else. Do you have any ideas for a name? But if I didn't, I would also do that. I could do this. Thesaurus. That's not what I want. What the heck is that? Oh, food place. All right. Sure. Thesaurus, we'll do location and see what options they give me. Area, that could be nice. A site, that's a term I've heard before. Could even do spot, because we did mention that there's going to be several locations at a location. So the warehouse is going to have several areas in the location. So we could use spots. Station, that could be the name for a physical location. Anybody see one that they like? Venue.
I think site would be good because that's what they usually call them.
Yeah, warehouses are usually called sites, and then
Yep.
if I really want to get specific, we could even call the items inside of a site are spots. So sites have a bunch of spots inside of them. And that way location can be on the item that's saying where it is. So a location can be a spot, can be a person. So location can be either a spot or a person. So we're gonna have site and spot.
And interesting though, region also could be region of a bunch of facilities together. You can also use region for inside the warehouse as well. That's kind of fun, two things too.
People.
Hmm.
People. So yeah, those are kind of the three things. So sites is like your warehouse, and then a spot is a specific location in the site. And so a item will never use a site. An item will either have a spot or a person. And that's what I'm thinking here. The spot, of course, can let me know where what site it's in. So the spot, of course, if I think about relationships, the spot can tell me the site that it's in. That's why I keep sites separate, and that'll be like a one-to-many. A spot has one site, whereas I can have many spots. So I'm already thinking of that. And this is, again, why it's helpful to understand how relationships work, because you can come up with better models if you think of this. So I got sites and spots, I got people, and then items, I can have a location. The key thing here we're trying to think about is I would have to really dig into how can I have a field refer to either a spot or a person. And this might work with, I would have to look into how can JPA work with interfaces? We know that Java has a system that would allow me to do that, where if I have an interface called location, so if I had a location interface, so Spot could implement it. So that's one thing I could do. Look into seeing how JPA would handle that. That I could have a location interface, and that Spot and people would implement those. Can JPA create an entity around that, right? That makes sense? So this is something I would look into and see how I could handle that. And with looking into that, I'm either going to find that, yes, JPA can handle interfaces, or I'm going to find how someone else implemented this kind of system. And that'll help me to understand, is this going to be a location spot and location person? And if one isn't filled, look at the other. So I could have two lookups if it's where it is, see it's one or the other. Or yes, I will find out that I can use a interface. So that's going to be a cool thing there. If SQL will allow us that. I know I could do a concept of a many-to-many relationship that would be like item ID, spot ID, people ID. And while this is a required, only one of these two are required. So the idea here would be that I could have a kind of many-to-many relationship that the item will have either a spot or a people ID. And this wouldn't necessarily be a many. It would be a table that I would create saying, this would be the location element. Yeah, this would be location if I can't do interface. So again, if I can't do interfaces, if JPA can't handle that, this would be my location system. Item ID, spot ID, and people ID, where it's definitely gonna have an item. It's a required that it has an item, but it's gonna have at least one of either a spot or a people. So it's somewhere, right? And that way I can track that. And this would be a one-to-one, just to clarify, by the way. This would be a one-to-one because a location can only ever have one location, right? So this would be an entity that is a one-to-one between the item and the location entity. Does that make sense? This way, it's a one-to-one that this data is held in a table, right? Yeah. So that's how I would get around the interface if I can't figure that out. But I would do some Googling on that. 'Cause I don't know if it can handle it off myself because I've never done it before. But that's, again, this is why the planning phase is so good, because it can help me to realize, ooh, what do I need to investigate? What do I need to look up? So again, I would do this. Check if JPA can use a location interface. All right, so Spot would have name, V1, physical address might be nice to have. So if I want to do a mapping of where it is, great. Not really needed. Spots. This would be probably, again, name, but it would be more of like a code name for the store, code name. Do it all how I use, by the way. I'm going to do this site. So I'm trying to think of how to make this understandable to what it is. Showing that Spot is kind of really like connected to site directly, right? So one of the downsides of using text-based instead of a whiteboard is I have to be creative in how to showcase my thoughts with text and things like that. So I got to be very creative in that. Where for some people, yeah, text works. Notes, again, well, I'm doing this on a computer. You can do this on a notepad or something, on pen and paper. I can't show that to you guys via a Zoom session, so I'm using a text editor for that. But if you're someone that's very much hands-on, wants to write things out, do this on pen and paper. You don't have to add it to your project. With these now, I'm going to go ahead and do model, new. Let's add a location. Call that an interface. I'm going to say location at the moment. I'm going to add a comment here saying might. Just remind myself. Notes. I'll go ahead and create a site item and a spot. So model Java class. Oop, curtains in. Site. Model new Java class. Spot. Model class. So now is it out? Now I need to ask, this is probably something I would go back to the user to ask them, is like, is it guaranteed that anyone who's going to be accepting the item has to be a user of the application, right? Or is it going to be to a point where I can just, let's say I'm going to have a virtual tag that the person receiving this isn't expected to use this application, isn't expected to use it on their own phone, that the delivery person is just going to scan saying that they delivered it to this person. And then they're just going to say delivery finished. And that we can then attach it to a person like a client, if that makes sense. So what would you think on that, Taylor? Would you want to require people to use the app as a user, or would you be willing to do client-based where the employee is going to go up, they're just going to mark it as delivered, and then you'll move the item to the customer?
I'm more open to the employee side of things where they do the confirmation for the client.
Then we'll have a client class then, and a user class. So client.
It could get messy with having, even in a simple form
Yeah.
of just a link confirming that they received something, but then
Yeah.
errors could come on the client's end. Even if they're well-intentioned, I would want to remove that issue and say, okay, we have to be on our game when it comes to the relationships that we have in our product.
Yes, and that's exactly why I came up with them. Like, I thought for a second, like, wait a minute. I just realized I don't like the idea of the user of the person at the house actually using their phone and using our app and being able to
Right.
do that and
Because
relying them to it.
FedEx doesn't always ask us, hey, do you want to get your packages texted or whatever? No, they just drop it off unless it needs to be signed off on.
Yep. So I realized that. So yeah, we have a client, then we can have, just users in that case. So, or employees. We could even call it transporter, because I guess you could also use a third-party person to transport it, and if they're a partner with the app, because that could be something in the future. We'll do employee for now, but potential future update. Sure. Transporters. Non-company, so your company uses our app. Any transport company that also uses our app can be connected to your inventory and be able to use it. So since it is a web-based app, you could enable for integrations with other companies so that they can then scan your codes. that could be a cool little future feature. So transporters can come in as again, they're not connected to your company, but because you've authenticated them with your company, they can scan your codes and take items. You can even set restrictions on what they can take. So that could be a cool little feature in the future.
Absolutely. Just a practical example of work, even today, for some reason, our application has a whole process that if we're supposed to receive a certain quantity of whatever product and we put a number that's bigger than what the paperwork or whatever says, it asks us to confirm, are you sure you want to receive in this many? And if you say yes, then it will retroactively update that in the system, even if it's not there. And it was a whole issue of running around having to find stuff that wasn't there and looking in the logs of why did they do this and finding out, oh, so it was never here. He realized what he did, but then of course never received the fake product in. It was just hovering. So in my mind, I'm breaking it down. There's a two-step process that goes with this. If an employee should do this, in my response saying, okay, only a manager or someone of a higher authority should have the ability to do this function.
Interesting. Yeah, so crazy.
Yeah.
But
That
like I
was a
said, that's why
feature.
future features, keep them simple in the beginning, so that it's, but as your users use it, you will find where the weaknesses and where the improvements can come into play and what sort of security and settings you need to add. We're going to, again, we always approach our projects in the beginning for version 1, we approach our projects as if we have perfect users, even though that's a very, very bad fever dream. You never get perfect users. You always get someone who doesn't behave right. So, but if you code for that, you'll spend months trying to catch every single mistake a user can do and every single way a user can make mistakes. So plan your program as if you're using perfect users. But if you think of something that sounds easy to catch, go for it. But again, you can also just mark that as a future item that you can add in once the basic functionality is there. So your error checking, your validation, your protection systems, those can come a little bit later once the basic core piece works. Again, one of the main reasons why we do this is if you start adding in error catching or validation or security systems or restrictions via authentication stuff and rights, when something doesn't work, you don't know if it's the logic of the action or the restrictions that are actually preventing it. And that's where you can run into that problem of having to be like, well, wait, is it because I'm not allowed, or is this because the logic is bad and the action doesn't work? So that's why we always want to take our code and start and plan with perfect users. Because if we know that works and we add this security feature, or we add this restriction system in there, and suddenly our feature stops working, we know it's due to the new thing we just added and the logic, the behavior is correct. And so it's going to save you some headaches. So you got that. So site, employee, client, item, location, site, and spot. These, I think, are going to be the main items I have, other than auth, of course. And so from here, what I can do now is I can add my notes to each item about what I might want to put in there. So this is where the IntelliJ side and where I can now put my to-dos in. And so this variation, instead of using the Trello system, what I'm going to do is I'm going to use the to-do system to kind of create my tasks. The downside of this one is that, like I said, I don't know the full features of Java's to-do, if I can sort them or organize them. I don't think you can, but we're going to find out what we can do in IntelliJ. So if I want a client, you might want to create a what's what I'm looking for? I forgot my word. A macro for this. So a key, like a quick little key press you can type in to have it create this automatically for you, just like this. So I hit like Command Shift 7 or something like that. It'll pop the to-do line for me. Got that. I'm sure I feel like there should be a shortcut from. Hey, there we go. Ooh, that's nice.
date?
I was like, say, there's got to be something from IntelliJ. As soon as I said, like, IntelliJ's got to have something. So you just type the word to do and hit enter. It'll add that for you. Cool. Okay. To do. Add client fields. Setters. Just make sure I don't forget them. Do a to do. Dang it. So don't hit the space bar, otherwise it won't work. To do. Create repository. Roller. And here I can also do a tab slash. Think of some of the requests I might want. A get one. Yeah, if I want to get one client, be able to pull a single client from them. So I can get the QR code or get the stat, add them to a ticket or something, or be able to connect them somehow. So we can do a get one. I definitely want to be able to add one. So add one. I'll probably want to be able to edit a client in case they need to make changes to them. So edit a client, edit one, and I can't think of a reason why I might want to delete a client for historic records, but I might be able to. I might want to do like a soft deletion where they can't be accessed, where I can't give them an item anymore. So I might want to think soft deletion, but I don't need to worry about that right now for version 1. So that would be my, and I would do this for every single one of my items here. As again, once I'm ready to work on that task, I can then say, yeah, nope, can't move them. So like I said, that's one of the downsides of using this versus Trello. Trello, I can move things around, I can select things, I can have that moving process where I can slowly move them along the progress of how they're being completed. With this, I just see a list. And with this, I didn't have to manage myself. But again, if you're someone who's very big on the pen and paper, you can kind of do your Trello on pen and paper. So you can come here, see all your to-dos, see the file that they're on, see where they're going on, and then decide to be like, no, I'm going to do this one and this one. And so I'll write client 5.8. So it does kind of have a code for them. So on my paper, I'm gonna be like, what I'm going to do today, I'm going to do client 5.8, client 6.8, and client 7.8 today. And you write that on your paper. So you physically write and you make that promise to yourself, just like we did in Trello by moving stuff to in progress. So you can still do that yourself. And again, if you're someone that works better with pen and paper versus trying to have multiple tabs on your screen. If you're someone who doesn't like to switch around and keep going back to Trello on a screen, and you'd rather just go to the side paper and write it down or mark notes or cross things off. If that works better for you to keep yourself organized, this can work for you. But again, this is where I would start. And I would do a similar thing in my front end once I'm ready for that. And again, like I said before, my notes is going to dictate my backend. My user scenarios is going to dictate these. And then from there, I will build that out only what I need for the API. I then let the front end consider all those other items, like what sort of search systems am I going to want? Am I going to want to search by client? Am I going to want to be able to by client ID? Am I going to be able to want to search by site ID or something, or find the all or get all the sites under all the spots under a certain site? Do I want to be able to, do I need all that? Do I need to be able to find all the spots under a site? Do I ever need to list that out? I can't think of a reason why I would need that, but maybe I do. And the front end will let me know that I do, and then I can add that later. If I can't think of a reason for that route, I'm not going to waste my time and build it. I'm going to build just what I know I need to be able to do what I think needs to be done. And then the front end will show me, yep, you've needed this, you forgot about it, go ahead and add it. And that's how I minimize my work on these projects and be able to make sure I build only what I need to get the minimum done so I can finish the project in a recent time frame. That makes sense? How that works? Good. Any questions? Anything? Do you want me to do a little more? Any questions on this? Any items I need to clarify a bit for anybody? If anyone doesn't understand an item? Or do we kind of see how the items might work? The one thing I'm hoping is that some of you guys are also, as I'm working through this, you're kind of seeing maybe in your head what some of the code might look like or how you might implement this. Are you guys, some of you kind of seeing that? Where my breakdown is kind of making sense of how you could probably build this.
Definitely
Nice.
helps.
Good, okay, so you're kind of seeing like through this walkthrough, you're kind of getting an idea of how you might build this through this walkthrough, right? Even though it's not your project, this is Taylor's, but some of you guys who never thought of this project before, never thought of creating this, are starting to see how you might, right?
Yeah, I feel like my weakest point is always like the planning phase. Like I feel like I just suck at it, but you know.
Yeah, that's why I wanted to bring these little sessions in. I know that this is going to be the hardest. Creating your own project is one of the hardest things for a developer to do. Creating something of your own volition with no guidance, with no steps provided to you by an instructor, being told, hey, build this thing, have fun. It can be one of the hardest things for a developer to do because you're not sure if you're even walking down the right path. you're not sure if what you see in front of you is the way you should build it, how you should build it, and how you should approach it. So, and it's one of the biggest concerns people tend to give me. So I wanted to run a couple of these sessions with you guys. I figured seeing a planning phase can help you come up with how you're going to plan so you can run it yourself. So what I'm going to say now for this one, now that we've done two, so now there's two videos again, I'll post both these videos on the playlist as soon as I can. What I'm going to challenge you guys to do now is to actually do your own planning phase. I'm hoping maybe to do one more before the weekend. And so what'll happen is this will be an assignment for next week to finish. If you haven't actually done a planning phase like this, where you really did, it took like an hour of your own time, maybe an hour and a half of your own time to just plan your project, I'm going to task you to do that now. And following some of these practices, either build a Trello system, build a to-do list, create your roadmap. And that's what you're going to submit to me. I want you guys to submit in your own format, whatever it's going to be, whether it's Trello, a Google Doc, a spreadsheet, a Scratch file, whatever it is. Submit a picture of a pad and paper. I don't care what it is. I want to be able to see next week on, let's say we'll do, since this is the project, we'll actually do Monday because OpenShift. So on Monday, because we want to host our projects and stuff, I think that'll be a project day. I'm trying to think actually, because it's either a Monday or Thursday thing. What do we think? It's not an algorithm thing. Roadmap. Do you want to do Monday?
I'll write
or
a program
Thursday?
to write my roadmap.
No, I want you guys to get this project done. So I'm not going to waste time. We'll do Monday. All right. I want to make sure you guys are keeping on top of your projects and not waiting on this. We want to get these done because again, we're trying to get a lot of you guys done by this month. So Monday, roadmap for your project. If you haven't written one out yet, you should have one now. It can be definitely skewed towards what you've already built. So if you've already been building it, if you skew it towards what you've already built, that's fine. But you want to make sure you have a roadmap for the stuff you haven't built yet. That makes sense? Cool. I'm thinking we'll probably do one more of these before the weekend. So we'll do one more of these. We can see another variation on how we do this. I'll try to come up with another way of planning it so you guys can see a third instance. If someone wants to give me an idea of how they plan stuff and I can show you how I would do that, that's fine. But I will have a third way of showing this. We'll probably do one more at least. And yeah, if you guys keep liking it, like I said, if we ever have free time at the end of class, or if we have a session like this where no one has questions, we can do one of these. Sound good? All right. Taylor, since it's your project, any questions?
I love a lot of these ideas I already had and I've already started implementing. I love the client idea. That's something that I kind of did. What's the word? I didn't think of it initially because my mind just went to, okay, at least the managing items from one place to another. But ultimately, the goal is wherever it's going to be, there might be a client involved. So that's something I'm going to start kind of writing notes on what I would want that to look like.
Yeah. Sorry, I thought you mentioned like renting out. I thought I heard that during the pitch that there was like a session like renting out items too, managing that stuff too.
Well, I have that background of having equipment rented to a customer.
That's
for
where I
the
heard it.
events
Okay.
that I did. Yeah.
Yeah,
So
that's where client came into my mind.
right. But that's also very true because I do want
Yeah.
this to be as broad scale as possible for use of whatever industry this may or may not go in, from enterprise level to, again, small business, that they would, if they want to interact with a client, they have to have a way of tracking that.
Good. Okay. I just want to make sure I was on the same page. Like I was like I heard you say rental. So like, oh, okay, cool. So he's going to want to rent these things too. So
Yeah.
that's why I added it to the project. So glad that actually worked out for you and that you weren't actually considering that at first. So there you go.
Yeah. I'm going to go to town on that.
I will double check on the whole interface JPA thing. And if I find an article for you that on you guys, I'll share that with you guys. So if any of your projects might benefit from that, you'll have an article on it. I don't know if we'll do a class for it. See. But I will share that with if I do find an article on how that works, JPA interfaces and how those entities work, I'll share that with you all. All right. I feel like you can. I feel like that's something I've seen before. Again, I couldn't really implement it to the projects we've been building. So it wasn't something I've instructed you guys on. It's more of an advanced feature. So nothing you need to know to really get a job, but if your projects could benefit from it, I will at least give you guys a article or a YouTube video on it, how it works. So you guys can, if you need it for your project, you can learn to see how to implement it. So that the open session's over, we'll do a 10-minute, maybe 15, because I got to check quick on the thing that Arnell called me on. But I also got to talk to Leah. So we'll probably do like a 15-minute break. But I'll do a 10-minute timer and just, yeah, as soon as the 10 minutes timer, just as long as you're by your computer, you're good. I forgot to listen to the timer that was provided to me yesterday. So I'm going to just skip through it a couple seconds and see if I'm okay with it. Is Nathan even here? I didn't do the attendance yet. By the way, reminder, attendance. It was not, yeah, Nathan, there he is.
I'm here.
No, I'm not gonna use it if you're not here.
Yeah, I gotta fill out the form right now.
All
I
right,
skipped
I guess
around it
it's
a little
fine.
bit and I didn't hear
Yeah.
any.
No,
anything.
it seems fine. So whatever. No one else provided me a
Let's
link,
get
so
risky.
you win. Yep. I didn't say you couldn't, it couldn't be gaming related. Like I said, you got around it, so. And go. Just, the music has nothing to do with the game, it's just the background. I checked that. So, whatever. So yeah, keep, like I say, as long as you continue to hear the audio, you should be good. I don't believe this shares with the break. I don't know how the breakout rooms work. Hold on. If I go to a breakout room to talk to Leah, this is gonna not work. Crap. Didn't think of that. You know what, I'm gonna do so the first 5 minutes of the timer won't be active. I'm gonna go talk to Leah first, and then when I come back, I'll start the timer and I'll adjust it as needed. All right.
Okay.
Leah, just head over to breakout room 1. Ooh, I gotta pause that. So because this is a container of balls, I'm gonna be saying balls a lot, which is gonna be fun for the video. So let's get through it. We have a container full of colored balls. The concept is that there's always the same number of balls in each container to start with. So but the thing is, we're trying to see, based on the disorganized number of balls, can we sort them in a way where each container has the same colored balls? So in this case, we have red and green balls in 2 containers. There's 5 in each. We just want to see, can we do 5 in 1 and 5 in, and 5 of red and 5 of green? Now, again, as you guys as humans looking at this, can we? Why?
There's too many red.
Right, we can just glance and say, hey, too many reds, right? That's one of the benefits of being a computer, of a human. We can just look at the thing in general and just make a quick assumption. We know computers can't do that. And in the same sense, there's going to be multiple containers. I will give you guys, the main hints are going to be the constraints, so we can save time on this. There will always be the same number of containers as there are number of colors. So if there's 3 colors, there's 3 containers. If there are 5 colors, there's 5 containers. Jeff's got a question. I'm going to check the chat. Probably, yeah. Again, if you, I mentioned it before, you probably want to have a HackerRank project on GitHub, on your HackerRank and on GitHub, and just you can make a separate class, a static class for each one of these that you can then run the method of. So you can just do the class dot method and run it. So a static method class for each one of these, and that's all you need to do. And that way, if you have that project, you can just push that project to GitHub, use your algorithm project, your Java algorithms project. That is a project you could theoretically even add to a resume to show just a skill set and a large level of practice in Java algorithms, if there's enough items on it. So you want to make sure you're getting your credit on GitHub. So yeah. Okay. So yeah, those are gonna be the same number of, and then each basket will have the same number of balls. So if one container has 7 balls, all of them have 7 balls. All right, so those are your constraints. You can look at them again to be more clear on them, but yeah, definitely check them out, make sure they make sense. So again, another sample you see here. We can make the swap and see that, yep, 2 and 2, we're good to go. The last thing is that there's multiple test cases, but again, you don't have to handle that. You just need to make sure that with your, before I look at that, let's refresh just in case. Be careful on that. So refresh. Now we can take a look. We can see we just need to handle a single test scenario. As long as your function can handle a single test scenario, it'll handle the multiple. You'll get a 2-dimensional list of the numbers. So that's it. Feel free to go through. Let's do this quick, actually. Let's do first 5 minutes where you guys can read through this, look through it and ask, and you'll have an open floor for, and then we'll do another 5 minutes of it, open floor of questions. All right. All right. If you feel like you understand it, you can give me a thumbs up reaction. If I see enough of them, I'll end the timer early. So 5 minutes, look over the problem, look through it, look at the examples, make sure it makes sense.
What section of HackerRank was this problem in?
I didn't share the link yet. That would be
Oh.
helpful.
You can find it if you just use the search function.
Yeah, organizing containers of balls. You can look that up if you need to, but I'll also put it in the Slack or the chat. I'll put it in the Zoom. Oh, never mind. Evan got it. Thank you, Evan.
Yep, no problem.
I got something. All right. Restart that.
I
Time.
usually just work from the editor to give us.
All good. All right. So yeah, 5 minutes, read through it, think of your questions, and then we'll do another like 5 minutes or so of like asking questions, 5 to 10 minutes, and then we'll set a 45-minute timer for you guys to attempt it and see how far you get. So once you're ready, you can just give me a thumbs up reaction. Oh, actually do the yes reaction. That way it stays. Sorry. Forgot the thumbs will go away. So use the yes reaction so that it stays on screen. I can keep it. I can see who said yes.
Wait, what are we saying yes to? I'm sorry, I missed that part.
Once if you feel ready to move on to the question stage, like you've read through it and you have your questions ready or you understand the problem, just use the yes. That way, if I need to, I can end the 5 minutes early. That way we're not just sitting here waiting. So,
Okay.
yep. That's 5 minutes. So first question, so before you guys ask your questions and stuff, I'm gonna ask a question to you guys. Anyone know why I put a 5-minute timer down for understanding the problem?
Typically, that's how it is if in an interview.
It's related to that, yeah. Not because you need to understand it within a problem, within 5 minutes. Take whatever time you need to understand a problem. Whatever time you need, take it. What I want to do though is let you guys realize how quick that 5 minutes can go. That if you have an hour-and-a-half long time to do your HackerRank interview or test, 5 minutes can go by quick, especially in the beginning of the algorithm. So it's not to say you have to understand this quickly. You just need to be aware of how much time you are spending on each task, on each part of the algorithm. So again, take the time you need to understand it, because you can't write the code if you do not understand the problem. Like we said before, code doesn't solve an algorithm. The human solves it, and then you tell the computer how to do it. So if you don't understand the problem, there's no way in hell you're telling the computer how to do it. That's also gonna be a weird 5-minute random gap of just nothingness in the video. Damn it. Anyway, so just skip through that when you go through watch this video again. So yeah, that's why I'm doing this. I'm not saying you have to be able to understand, but you want to try to find techniques that can help you to understand a problem better. Know where you need to go to in the problem to understand the problem. Know where your weaknesses are in algorithms, so you know to make sure you know where to spend extra time reading and less time. So skim the story, but read the details. Learn how to skim the story, but extract the important information. And just be aware of your time. For some people, especially for me, if I'm doing something that's very, very time-based, I might set up, I have a little Pomodoro clock here. It's a little Pomodoro clock. All I can do is I flip it and it sets little timers for different ranges. So everything from 0, 5, 15, 30, 45, and 60 minutes. So I can set that, just do a quick 5-minute timer, just so I'm aware, hey, 5 minutes has passed. Or I can set it to 15, just so that I know 15 minutes has passed. What are you doing? Making sure that I stay on target, stay focused, brings me back to reality, and helps me to realize what kind of time is passing. If you're someone that can very easily lose track of time, might not be a bad idea to look at, like, you don't need to get a clock of your own and spend money, just get a phone app for it. There's even probably extensions for Chrome that you can get for it. So just be aware that that is going to be massive. That can be very helpful, just being aware of your time frame. But definitely take whatever time you need to understand the problem. You cannot solve it if you don't understand it. The next thing I will say, remember to do the planning phase. Take a couple minutes, write out your thoughts. Since you'll be in your own breakout room, you can actually go ahead and do a share screen with a whiteboard. If you don't have a whiteboard at home, you can use that to draw out your plan, write out your plan with the mouse. You can open a text pad, use a piece of paper, whatever you need, plan out your attack. Remember that, especially with these medium ones. If you go into a breakout room and you start writing code immediately, you're a little disappointed in it. Make sure you know what your plan is, what your solution is, and how you're going to approach this problem. Try to solve the 2 examples that you see there. How do you prove that first example? How can you get a computer to prove that first example is a no? And how do you get the computer to prove that second answer is a yes? How do you get a computer to do that? And then come up with your own examples, or help. Looking at the screen right now that I have on screen, I'm perfectly fine just doing this. Run code and take a look at the sample cases and see if I can solve those, because they'll tell me, oh, well, I first got to do a return, but I will do that first. So I need to return a string, so. Not gonna work, but it'll at least make the code happy. And at least runs, and then I can look at the test cases here and see if there's any additional examples that weren't above. So we know these, I think this one right here is the example above, and this is a different example. So I could use this one and see what's going on here. And this one, I think this guy is the example above, and this is no, these are different examples altogether. These are both 3-bin ones. These are both 3 bins. So these are 3 completely unrelated items that we've seen, but I can see that this one is supposed to be impossible and this one should be possible. And so then I can figure out, hey, can I understand how to get a computer to tell that this one is impossible, and how can I get a computer to determine that this one is possible? So those are the tricks that I've used as well. Run it, just get it to run, look at the sample test cases, and then make sure that my understanding of the problem, my current solution can solve these before I write any code. That makes sense?
Mm-hmm.
And I will say, out of 45 minutes, it is okay to spend 15 to 25 of that coming up with a process, coming up with a solution. Writing code does not take a long time if you know what you're typing, if you know what you're coding. It takes a long time if you're coming up with it as if you're coming up with a solution as you type, because then you're correcting and adjusting and changing things and trying. And a lot of times you're also then later on, if you realize there's something wrong with your code, you're going to try to get that code to still work instead of trying to delete it. If you realize during your planning phase that your solution is crap, it's a lot easier to fix it because you're not deleting code. So make sure to take care of that. Again, the better you get at algorithm, the less you'll have to do the planning phase. But until you get good at algorithms, take advantage of that. And no matter what, the harder the problem, the more likely, no matter how skilled you are, you're still going to run a planning phase. I talked about that with the Code Jam. I was so impressed with how many of those finalists around the world had a major planning phase for each challenge. They did not write code immediately. They planned it out. All right, now I'll open the floor. Questions for you guys. Anybody have any questions or things that are a little unclear here?
So in the first example that we have right
Mhm.
there with containers equals the nested array,
Yeah.
it's the locations, or rather it's the indexes that determine the type of ball, and the number there is how many of that type, right?
Yeah, so
Okay.
your first dimension
Mhm.
is the container number. So, I should have kept my stupid whiteboard plugged in. Oh, I didn't plug it in. I did the note thing. I meant to plug it in. Let me plug it in.
I spent
Leah,
too
you don't know
long
now.
looking at.
I got this
I
now.
Ooh, nice.
So I thought I showed you this. Yeah, Leah doesn't know. I now have a tablet, so I can draw on the screen now.
Oh.
So we can do
I haven't
whiteboard
seen
sessions.
the tablet. Wow. Yeah.
Oh, Leah was back with me. Leah originally took the class when we were back in person, so she knows how much I like my whiteboards. And then we moved to virtual, and I really couldn't do that anymore. So I decided, screw it, I'm getting this because I need to be able to do my whiteboards. So, I think Gabe and Margie have both been mentioning that they want to get one. So, because then again, I've heard that Gabe has gotten really good at drawing with his mouse. So anyway, so yeah, when you get the matrix, so this right here is actually going to look like this: 1, 4 bracket 2, 3. So that's what it'll look like if you write it out. So
Mhm.
the indexes of the array, this is box 0 and box 1. And then this, instead of saying color red, green, and red, you have color 0 and color
Okay.
1, color 0, color 1. So you don't actually have colors. You could also just assume that they're just balls with numbers on them. So you have a
Okay.
bunch of, we have 1 0 ball and 4 1 balls. And in this bin, we have 2 0 balls and 3 1 balls. So think of it in the sense of pool. There we go. That's the word. That's the game that has numbered balls, right? Pool.
Oh yeah.
Yeah.
Mhm.
People, how many people thought water? No.
No,
I heard
Uh,
cool and I got really
Oh.
confused.
when you said
Gotcha,
pool,
yeah.
I immediately
I was thinking
associated
water
with the
polo when you said pool.
water.
There you go. No, like, yeah, pool with a stick. Which water polo I think has a stick. Never mind. That didn't work. Anyway, but yeah, so that's what we're looking at. That makes sense?
Mhm.
Cool. So yeah, don't think of it in colors as actual colors. Think of it as, again, numbers. Any other questions to clarify as you need? It's the time to ask it.
That square really represents, when you put that little arrow, really represents on how the matrix works.
How the matrix is laid out. Yeah.
Yeah.
And yeah, keep aware, guys, in your homework that I gave you with the algorithm data structure stuff, this was one of your extra words there. It's kind of hinting at what that might be.
So we're sorting them based on the index that they are generated in.
Not necessarily. Again, the number 1 balls do not have to go in the one container. The number 1 balls can go into this container. All you're trying to determine is if it's possible, to make sure that each container holds only one type of ball.
Okay, so the numbers are just saying if it's a number 1, it should be in the first container in this instance.
Again,
or
doesn't
the
need
second,
to.
whatever
Yeah.
it is.
Yeah, in this case, yeah, if you were actually doing the sorting yourself, you would try to fill this one up because it's already mostly full. Of
Yep.
course, 'cause I wouldn't want to try to put all the ones in here and all the zeros here.
Sure.
And you're only moving balls by swapping. You're never taking a ball by itself and moving it over. You're always swapping
Right,
the
1
balls.
for 1, yeah,
Yeah, always doing a 1-for-1 swap.
okay. That helps.
And that's why this one doesn't work eventually, because at some point you're going to have a bin with all red, and then a bin with this is 0. And so you'll then notice like, hey,
Possible,
there's
yeah.
no, I can't, there's no 0 over here I can trade a 1 for. So,
Impossible case, but
yeah, so that's one way you can determine a possible case. Any other clarifiers? Yeah, the main thing that makes everybody clear, ball 1 does not need to go in box 1. Ball 2 does not need to go in box 2. Ball 3 does not need to go in box 3. That does not matter. You just need to know that for each container, can I have just one type of ball in there? Final call.
So the numbers that represent the types of balls.
Like I said, yeah, it's the type of ball. It's like I said, they say they're colors. I'm gonna say look at them as like pool balls. So, you know, the pool balls have the number on them. So we just have a container here with 1 0 ball, or in this case, a cue ball, and then a bunch of 1 pool balls. Let's just say we're running a pool hall. So we're a company running a pool hall. At the end of the night, we want to take all the balls off and want to make sure that they're in there. And for some reason, the person who cleared the tables mixed all the balls. It's like, no. We want them. This is the one. We want all the ones in one bin, all the 2s in another bin, all the 3s in another bin, and all the cues in one bin. The bins aren't labeled. That's the main key thing here. The bins aren't labeled, but we are using a number to point at them. If you had a bunch of bins lined up against the wall and you wanted to tell someone to put something in a certain bin, you would say the second one from the left, right? And so you would give it a number. So numbering the containers is a thing, but that doesn't mean that that has to hold the number 2 ball. Yeah, the numbers just represent it's a different ball. And whatever makes sense in your head, colors, pool balls, whatever. Any other questions?
Can we take a look at the sample that it gives us of the actual code? Because I feel like it was confusing seeing the sample case and then seeing, yeah, the code block, sorry.
Code block.
Oh, yeah, right there,
These?
sample.
Oh, okay.
Yeah, yeah, just, so 2 at the top of the code is saying that there will be 2 different sets of bins that will be implemented. 3, it says
No.
that.
So this is 2 test cases. So there's 2
Right.
sets that we're gonna run. This says there's 3 bins and as such 3 colors. So 3 bins and 3 colors.
Okay, gotcha.
This is bin 0, bin 1, bin 2, color 0, color 1, color 2.
I see, okay.
Yep.
Gotcha.
Good question. Good clarifier. Yep. And that's why, yeah, that's why when you do that, you can then realize that the second set here is again another 3 bin set. 0, 2, 1, 1, 1, 1, 2, 0, 0. Yep. And a 0 here just means that there are none of that ball in that bin. So this bin has 2 1 balls and one 2 ball, but no 0 balls. That's what that means. All right, I think that's enough for the question. So again, last couple things I'm going to give you guys for this one. Remember data structures. Think about that. I chose to start with a somewhat harder one as a starting point, so that everyone there's a higher chance that more people will struggle a bit. So you do feel that, and it's also going to help you to kind of identify who in the group is going to be the to-go people for the rest of you. If you have an algorithm problem, if you have an algorithm question, if you're struggling in algorithms, we know who to kind of go out to. So if you're struggling with this, that is fine. That's why we're practicing. Do not panic and feel like, oh, I fail. I'm a failure. I can't do this. I am picking, this is a challenging challenge. And there are some really easy pitfalls in this that I want so bad to tell you guys that you don't go down it, but I am going to hold back on it. What I will probably do is, like I said, I'm going to start popping around to the rooms to see what you guys are doing. And if I see you might be going down the rabbit hole in about 10, 15 minutes, I'll start popping around. I'll let you know that that's the rabbit hole I was talking about. So then I'll stop you from going down it. All right. Last thing I'll say, well, yes, you are working on your own for 45 minutes. If you in a part where you are straight up stuck and you're spinning your wheels and you're not making for a progression, do not sit there for 45 minutes. Raise your hand so I can pop into the room and see if I can give you some assistance. All right. Sound good? All right, again, solo. So find your own. Actually, I can just rebuild the rooms and assign you a room and have it auto assign a room. That's going to be easier for you guys. So you guys trying to figure out, find a room that's by yourself. So stop share. I'm going to stop the recording. the 3, 3, 3. That's a weird 3. There we go. And so this is what we see, but this looks kind of confusing. And so another way you could look at it is when we do when we don't like having things like collections taking a long amount of lines, we'll do like JSON syntax, or we do this, then we do 1, 3, 1, 2, 1, 2, 3, 3, 3. And now that kind of looks like that same thing we saw on the images, right? We see this square. And this is really what a matrix is. And it really is. Each entity in the first dimension, each first dimension is a row, and the second dimension is your column. And if you think about how you access it, you do container dot get, you then give it the row. So if we want to get this 2 right here, what would I do? Get what?
But which
It would be
two?
one.
Yep.
1, right? So we get the 1 row, because this is row 0, row 1, and row 2. So we get 1, and then I get a list. And again, if I want to access something out of a list, what do?
Dot get again.
Exactly. Get again. And then what do I do to get this one?
Get 2.
And if I wanted to simplify this, I could say that this is 1, 2, right? The coordinates of 1, 2. So really it's just coordinates and that's how multidimensional arrays are. They're coordinates is how you look at them. The first dimension is your rows, second dimension is your columns. And it's always good to represent them this way. Like that, a matrix just means that even rows to columns, they're the same. That's all it means. So yeah, it's good to make sure that, and that's another thing I wanted to see. I want to know how many of you actually knew how to handle multidimensional arrays, because they are a fun item that people like to get into, or multidimensional collections. So we have that, but I want to make sure we understand how these look. And this one, I probably should have done this. I don't know why I didn't. But how this looks is each one of these inner bins, each brackets is a bin. So this is a bin. So I'll do this. This is a bin. And this is a bin. Just like we saw on the HackerRank. And each number is the quantity of that index. So in this case, there is 1 0 ball. So 0 ball. There's three balls. So three 1 balls. So there's a 1, a 1, and a 1. And there's 1 2 ball. Right? See how that works? Now do we see how this data represents to that? In this one, we have 2 0 balls. 1. That looks like there's a 2 in that. So I'm going to fix that ball. 1 ball and 2 balls. And here we have 3 0 balls, 3 1 balls, and 3 2 balls. So this was the first thing I kind of goofed up on you guys that I will take credit for. I made bad words, so I did bad words. I said that each of the balls each of the containers contain the same number of balls. And I accidentally made it sound like that they will have the same number of 5, 5, and 5. What I meant to say is that they'll have the same number of balls. They will keep the same number of balls. So this will always have 5 balls in it. This will always have 5 balls in it. This will always have 9 balls in it. That's what I meant to say. That their capacity will always be the same. What they hold will always be the same. That was something I goofed up on. But I tried to send out a broadcast message. I actually don't know what those look like and how many of you actually got those, but that was something I did flub a bit. So I do apologize for that.
Yeah, I saw that message.
Yeah, okay, cool. But that's something. And again, no matter what I tell you, always feel free to look at stuff. And if it looks different, and I said something wrong, again, I'm human. That's fine. It can happen. Don't take my words as biblical.
Because I didn't get that
Because-
message and I just assumed they would all have the same one.
Yeah.
And I only
Yeah,
got like
I
a
think I
couple
misinterpreted
cases.
it.
Yeah.
Like, I thought they would all have the same capacity, but then I found in a later case, that's not the case. Because like you said, in that third bin, that capacity is 9 balls.
Guys, not coming out of my headphones. I just realized. There we go. Okay. I just realized you guys are not going on my headphones. No, you are. Why are you popping up? Go away. All right. Someone say something just to confirm.
Check. Test,
There we
test.
go. Thank you. Perfect.
Ready.
Great.
Awesome. So this is what this looks like. And so how many of you guys went down the rabbit hole of thinking you actually had to move balls around? You can just do a
I-
reaction
for
and
a little
thumbs up
bit.
if you want.
Yeah, I got close to a little bit of
Yeah, you
thinking
can just
about
do
that.
yeah, you can just do a thumbs up if you thought about it. So well, I like the honesty. Thank you. I know some people are like, I don't want to admit that. That sounds stupid now that he says it.
I would say that I probably thought of that when I first attempted this.
I did when I first attempted this. I thought of that.
Definitely did.
I will say that.
And what's funny about it is that we technically don't. And if we think about what kind of logic that might so one of the ways I kind of evaluate if a idea is worth going down, I start thinking about what that would entail. How would I know where to move the balls? We did discuss that there's no guarantee that the balls don't belong to a certain container. So how do what would, just thinking of the potential logic would take to figure out where I should put the balls sounds massive to me, right? That already sounds massive. It's like, there's gotta be a way that I don't have to move these. Just that alone tells me there's gotta be a way that I can do it. That I can just look at this and be able to determine I can or can't do it without actually having to do it. That I can just determine it, right? And so what I started doing is I started looking, right. And so I started looking back at the visuals and the stuff and started making these visuals, asking myself, okay, if I was in a room and Leah was there with me, just to pick on you since you're the new one, Leah's there with me and I'm looking at the bins, I'm looking and I go, these are possible to sort. What's Leah gonna say? She's gonna question me, right? She's gonna be like, why? Why can you say that? How do you know that, right? I'm gonna question my statement. I hope you would question me. I hope you don't just take me at my word for it. At least not right away, until I start proving myself. But most of you would probably just be like, well, why do you say that? How do you know that? You're gonna ask me, how do I know that it's possible to sort the set? I then have to tell you how I know this. And so for algorithms where I'm not physically doing anything, where I can see physical movements and stuff, I use that as my way when I explain to someone why I can say what I say, that can help me find the algorithm. Because now I now need to, because that's telling me the conditions for making my statement. And we know the conditions are things that computers can do. And so if we look at some of those previous ones, so I'm going to switch back to the HackerRank for a second. Once I figure out where that was, I moved stuff around while you guys were away. There it is. Move this over here. There. Let's start with the easy one. Why can I tell someone that this that I'm paused? Why am I paused? Resume.
Do you still want to be showing the whiteboard?
Nope. That's why. There we go. There. So let's start with a new one. So this one's sorted. So I, of course, can definitely tell someone that this is possibly to be sorted because it already is sorted, right? But other than that, why can I tell someone that it's possible to sort these?
Because there's only 2 bins and 2 different types of balls.
Right. And they're there. Now, if I was to tell the person this one, these cannot be sorted. They're gonna ask why, and I can't just be like, look at it. Technically, this one, I'm pretty sure I could say that, but again, we want to actually be serious about it. So I say, we can't sort these. They're gonna say why. What would my answer be?
One color has more balls than a bin has capacity.
Too many red balls, right? Yeah, too many red balls. I can't do this. If I was to do this though, where I was move the 0 here and get rid of this ball, is that possible now? Why?
You have a 1-to-1 ratio of balls that need to get moved.
Kind of, but I also have what it is really, again, one thing we can think about. Oh, yes, I'll get that there. I don't want to say what it is. Right. I'm trying to help see if someone will say, so if I met with you and I gave you the two terms that are there, don't say them yourself, let somebody else kind of come to the conclusion. So if I told you the 2 keywords I'm looking for, don't give them away. Let the people can think of it. So this one right here, we know this one is impossible, but again, why? Looking at it right there, why can I say this is impossible?
Because the sum of one set of balls is greater than the size of the container.
That sounds interesting, right? There's how many, what's the quantity of the red ball?
Total of 7.
How many green balls are there?
3.
How many balls can container 10 hold?
5.
5.
How many balls can container 1 hold?
5.
Yeah, that doesn't match up. Let's see if this train of thought fits with the other ones. So if we go back down to, we'll use the bigger ones here, this one over here. Let's start with the impossible again, since we just found that. So we have a bin, so we have this bin with, actually, let's even stop using the bin now. Let's see if we can do this without the bin. So we have 1, 3, 1, 2, 1, 2, 3, 3, 3. So balls of type 0, how many are there?
1.
In this right here, right? There's 1 0 here, but how many in total? How many 0 balls are in total?
3.
5.
6.
6.
Oh, 6.
I'm getting a lot. How do we know? So
Oh.
for the 6, let's say the 6, how do we know that?
1 + 2 + 3.
Yeah.
1 + 2 + 3. We add up all of the quantities in the 0 index, because that's how many 0 balls are in this bin, how many 0 balls are in this bin, and how many 0 balls are in this bin. The reason why I say that is, again, how did you know that there were 3 balls here? You didn't look there and say, oh, there's 3. You counted 1 here and 2 here, right? That's why I'm trying to hint towards that. Make sure you guys see that. So we got that. So there, yes, there are 6 0 balls. How many 1 balls are there now? Now that we're on the same page.
7.
7.
Hey, good, we got the same numbers. No bad math this time. How many 2 balls are there?
6.
6.
Got it. So now let's think. So what was the next thing we did? We checked the what of the bins?
The
Capacity.
capacity.
So how many balls can bin 1 hold?
5.
5.
5, 5. Anybody else have a different number, or does 5 sound right?
There's 9 in the last bin.
Hold on. I want to make sure everybody's on the same page. Does anyone
Yes, there's
disagree that there's 5?
Yes, there's 5 in the first bin.
There's the capacity.
0 bin.
So can someone explain why it has a capacity of 5? How do you know that? What did you do?
I added all the numbers in the 0 bin.
Right? We add up how many of each ball they have in the bin. That tells us what that bin can hold. So this bin holds a total of 5 balls. This bin can store a total of how many?
5.
This bin can store a total of.
9.
So the same pattern seems to hit. We knew this was impossible, just like the last one. The pattern seems to hit. So now let's see if this concept, this train of thought, will tell us a solution is possible. So we'll get rid of these, because this only works if it works in both directions. So we know this one is possible based on this. So now our array is 0, 2, 1, 1, 1, 1.
Question
2,
about
0,
that.
0. Go
Is
for
the
it.
bin, is there only going to be 1 bin with that ball type in the end? Or
In the end, yes. That ball should have only
okay.
1 ball type in it. Yep. Each bin should only have 1 type of ball in it. So this, let's see again. So ball 0, how many 0 balls are there?
3.
3.
Good. How many 1 balls are
3.
there?
3.
3.
We have more than 1 person, that's all. So, how many 2 balls are there?
2.
2.
2.
Good. 1 + 1. How many balls can bin 1 hold?
3.
3.
3.
How many balls can bin 2 hold?
3.
3.
3.
How many balls can bin 3 hold?
2.
2.
I think I see a pattern here. What do you think?
Mhm.
And again, that's for
Definitely
me, again, the
possible.
biggest thing is just, I love visuals, not just writing out notes, not writing out text. For me, visuals can help me see more, because that's how I solve a problem a lot of times myself too. I will look at something and say, yep, this is good or not. And then I have to force myself to take those visuals and turn them into data. And that's the big thing here. Did anywhere in the problem, did it mention quantity of balls or capacity of bins? Was that mentioned ever in the
No.
problem?
No.
No. But this is data that you 100% have. There's a quantity of each type of ball and there's a capacity for each bin. And this is something, one of the main reasons I love this algorithm is because it shows something called hidden data. Very specific, obvious data in a solution that is never given to you, that you have, that is part of a solution, that can be part of a solution, but can also be useless, that you need to find. That helps you find the solution. they on purpose showed this concept of moving balls around to predispose you to wanting to move stuff into doing that. They did that on purpose on this because they don't want you to know the actual answer. They're just trying to prove the answer by saying, well, this is impossible because look, we can move these and now they're matched. Look, these are impossible because even if we move enough, we'll never get to be able to actually make them matched.
Yeah, but if you really look at the pictures though, they're moving them to 1-to-1. They're not really
Right.
showing you they're adding more or less.
Exactly. And that's again trying to get you to realize that capacity is a thing and it stays consistent in each bin, and that plays a role. And they're showing the layout of the balls in this case. So you can see the quantities. You can see that there are 3 total balls. It's very easy to see how many balls there are when they're visual like this versus like this. Even then, you can still see the quantity, but just going up and down. And across for capacity. So cross capacity, up and down, total quantity. And so this is one thing why I really like this problem is it shows, again, my biggest goal right now for the beginning of the algorithm exercising is to teach you the skills of problem solving, not necessarily coding yet. You guys know how to code. You guys can code. You guys know about for loops, conditionals, if statements. You know about lists, maybe not multiple lists and certain data structures, but in general, you know how to code. You know how to type JavaScript. And I know you can search for how to do certain things. Now, my biggest skill to have you guys learn is problem solving approaches, techniques, and skills. And one of these for this one is the idea of hidden data. Data points that are not given to you in the problem, but are there for you to be able to realize, I have this information. This is information that is available to me that I can see. Does it help me with the problem? Each bin has a capacity. Does that play a role in the solution? Each ball has a total number of them. Does that play a role? And that's one of those things you want to start to realize that as you go through problems, yeah, look at the data they explicitly give you, but then think about, well, what else is there here? What else, what other information is here? And what information is useful and what information is just fluff, right? The actual type of ball doesn't really matter. I don't even know if it's type 0, 1, 2, or 3. But the fact that there is 3 of 0, 1 of 1, 3 of 1, and 2 of 2, that matters. So now I'll have a new question. So now seeing this kind of concept of this hidden data and the pattern that we found, anyone see any sort of computational item that they could use to solve this problem? Matt, I'm gonna have you stay quiet unless no one can figure out because you technically said the answer when I was with you. So I'm gonna have you hold
Okay,
on.
because you worded it different and I had no idea what you were talking about until then.
Oh, you didn't realize you knew the answer. Okay.
Correct.
Yeah, I want to make sure I left out the 2 keywords that are here. So any computational item we can use. I'm trying very careful not to use the exact term. I'll use it in a second as a hint.
Hash map,
What was that? Who said
a
that?
hash map.
Richie. Yeah, Rich. Yes. Hash map, right? Look at this. Let me switch this quick. Let me just do a slight change and all of a sudden it'll pop out at you.
Okay.
Suddenly makes sense, right? Remember, hash maps, other than one-to-one parallels, they do frequencies. So they can keep track of how many of zeros we see as we iterate through the list. So we can iterate through here, count, oh, there's 2 zeros, 2 ones, 1, 2, and then total of 3 for capacity. We go to this array, we look through. When I add 1 to my 0, so now it's at 1, this is at 2, this is at 1 to start. Just so you guys see the process. I lost somebody. Who dropped? Oh, I already need to go. Okay. Makes sense. As we loop through this, we get 0 to start, 2 and 1. We then loop through here. We add 1 to each. So 1, 3, 2. And then we see 3 capacity, 3 capacity. We go through here. We add 2 to here. None, none. And then we get our parallels and compare and see, hey, for each, do I have enough capacities for each of these? So I can just say here and say, hey, do I have a bin that can store 3 numbers? Yep, I'm good. So let me eliminate that bin. Do I have a bin, another bin that can store 3? Yep, I have that. So let's wipe that bin clean. Do I have another bin that can store 2? Yep, I have that. And so I will give one more hint on this. For a highly efficient one, you're actually going to use 2 hash maps. One for your ball quantity and one for your capacity quantity.
Yay.
I thought about
2 hash
doing
maps.
that.
You
After
don't
I
need that.
complete-
That second one isn't needed. You could just create a list of capacities. So 3, 3, 2, and just say, hey, is there a 3 here? Yes, and then remove that item from the array or zero it out, whatever you need to do. Remove that so you can't double check it. So just remove that one from it. So it's like, hey, I need a 3. Yep, it's 3. I'll 0 it or -1 it, whatever, doesn't matter. Check the next one. Yep, I have it. -1. Do I need this? Yep, I'm good. All set. So you don't need the second hash map, but that would be the most efficient because then you wouldn't have to iterate through another second through this array with a large set. So 2 hash
I
maps
thought
would be
about that
fastest.
after I completed mine. I was like, well, can I solve this with a hash map? And I'm like, I looked at all of them, like, wherever I do, I'll have to put it into some type of collection or container to be able to compare both of them. So it just depends how big the set is. It depends how big the data I'm getting. It would dictate what I would use more efficiently to do the work.
Gotcha.
Yeah,
So
'cause
I
I
want to
did-
finish up because wow, it's already 9:30. Today went by fast. So there's a couple key elements that I wanted you guys to take out of today. One, algorithms can be much more complicated than when you first did algorithms in the class, where you could literally just dive in. Some of them require a good amount of thought process and thinking about the term. By the way, the term I was avoiding that Richie was able to get the answer to, the hint I would have dropped was the word data structure. I was avoiding saying that when I was saying what computational item do you want to use. I was trying to avoid saying data structure. So always think about data structures. But yeah, great answer there, Rich. Yeah, hash maps are 100% what you can use here. But the main key items that I want you guys to build out of this is practicing your planning phase. So honestly, just finding challenging problems and not even worry about the code. Just can you come up with a solution that is computational steps? That is something a computer can do. That is logical reasoning as to the answer that you're getting. Can you get the logical reason for the answer? Next thing is to recognize how fast time can go by when dealing with thought-intensive problems. So when dealing with an easier problem, you're pretty aware of the time because you're not putting all your thought process in it. When you're dealing with a problem that is a lot more thought-heavy, where you have to really plan and think about it, time can go by faster than you realize. And so I wanted you guys to realize just how quick 45 minutes went for a single problem, that it can go by pretty quick if you're not paying attention. So that was another thing for today. And just kind of get you guys reused to doing algorithms. Starting next week, we are going to start working on some simpler ones to start building up our confidence, start building up that process and start planning more. We'll also do we'll probably do a couple on Tuesday, and this time we'll probably do pair programming. So there'll be 2 of you working together this time, and 2 to 3, something like that. And then eventually we'll break out and do singles again. But for a couple challenges, we'll do pairs so that you guys can work off of each other and learn from each other until hopefully you'll start to learn how to handle it yourself. It's good to start with a partner so that you can kind of work off of each other and learn from each other how to approach problems and see how each other think. That can maybe help you to get better at thinking. And you're more likely to find things by just working off each other. I love a lot of times when I'm struggling with something and just talking through it with Arnell, even if he doesn't know the language. I'm just telling like, hey, this code isn't working. I don't know why. I told you guys about the PHP problem I had with on Monday morning, and he helped me with that. So he doesn't even have to know the language. Just talking about the problem, he can sometimes lead me to the solution. And that's why I'm telling you, and that's why I cannot stress it enough. Code doesn't solve your problems. Your brain and your thought process and your problem solving skills will solve them. You're then just translating your solution. Because like I said, I can get help from Arnell on a language he's never coded. He told me he hasn't coded PHP in over a decade. So when he helped me with PHP, he did not remember any of the PHP stuff. So I was not relying on his PHP skill. But he was able to help me figure out where my problem was. He was able to just talking back and forth and having someone that can respond to me once in a while can help me just keep moving down the path until I find something that I didn't see before. So that's why I'm going to start with doing some pair problem solving for a couple of solutions. Maybe 2 weeks we'll do that, and then the last week we'll go back to solos. Sound good?
Mhm.
For the homework though, try writing the code for this now. So you have 2 days for that. Definitely feel free to chat on Slack if anyone wants to do a organized session tomorrow. Let me know. I can.
to be writing the code.
You can, if you did, then great. But I'm just saying, my focus was today was. Did you solve it?
Yeah, I did.
You didn't say you did.
Oh, I didn't hear that question then.
Oh. Okay, then you're good for the homework. Then just work on your personal project. Yeah, if you haven't read the code yet, write it. If you have, then work on your project. What was I gonna say? Yeah, attempt to solve the problem now. If you guys want to do some sort of organized meetup tomorrow, you guys can let me know. I'll set up a Zoom for you guys. if you choose to do that. If not, it's fine. I'll be on Slack so you guys can post questions, but try to actually solve this now. So I've given you everything, all the tips you need to attempt it. It's up to you now to at least now put the code together. And we're gonna make sure that at the end of every challenge, we do solve it. That is the main goal. We never want an algorithm that you do not solve. But the goal here, of course, is making sure you understand the solution and you can see how you might get to it. So you can use this approach in future problems. The more algorithms you solve, the easier future algorithms become. Any questions? Leah, how was the first day of advanced?
Interesting. Challenging. You said
Yeah,
it.
it was interesting.
Welcome to the deep end.
I'm not gonna be bored.
Good, I like that. Awesome. And with that, I will see everybody on Thursday. All right, and like I said, Leah, I'll send you your links and invite you to everything. So when Leah will be in the cohort 12 chat shortly. You guys can say hi to her when you see her jump in.
Can I
Thanks,
talk
Lev.
to you one-on-one
Take care.
after
Of course.
everyone gets off? Okay.
Right, everybody.
Good night, everyone.
Have a good
Night.
night, everybody. Yeah. See you in the next one.
Yeah, I don't leave. And by the way, for people, I don't leave the meetings until everyone else is gone. So if you need to talk to me, you don't want people knowing you are, just wait.
No, you hang up.
Nice. I will actually take you to the waiting room.
All right. See you. Guys.
Hey, Jeremy. I love that
How
laugh.
do- That
Such
means
a
someone
deep
can
laugh.
stay until he gets tired of us.
I don't
Cliff,
get
you really helped my thought process there when you brought us all together. And you said each container had to keep its original capacity.
Yeah. That
That
was
kind
the
of was
thing
like,
you needed.
all right.
That was the thing. You're like, damn, I didn't see that.
Problem
'Cause I was-
the integers.
I was always looking at like how many balls were in each and how many of each color, but then I just couldn't put 2 and 2 together.
And then you're like, I was so close. I actually hate when that happens. Because like, why couldn't I get that trigger? What was missing? What did I need?
Right.
What were you saying, Freddie? What,
Did you
integers?
solve this with integers? If you did, Cliff?
What do you mean?
Because
Did I
I
solve
had
this
to
with
use
integers?
big ints because it was annoying and it overloaded and it went to negatives. So I had to
I'm not
change
aware
it
of
to
that.
big integers because I added all of the things in containers to get the capacity, and their test cases were over the integer amount.
Really? Oh wait, because I think
Yeah.
it says a 10 to the